Let's categorize the questions into 3 groups. The first group, the questions will be about circles. Second group, the dominant 5. Third group of questions, application of other topics. Here we go. We are given a circle here and a straight line. Let's read the information. They are saying in the diagram below, R is the center. So already we can see this is center away from origin. This is the center of the circle OPQ. So in this case, O is our origin. Let's write it as such. Point Q is the y-intercept. Remember from paper 1 functions, we learned that at the y-intercept, the x value 0. SQT is the tangent. So here we have the tangent SQT. The equation of SQT is this one. Whenever they give us the equation, we have to write some values that are important right from the equation. The equation of a straight line is in the general form y is mx plus c, where m is the gradient. So in this case, we have y is negative 3 over 4x minus 8. And from that, we can take the gradient negative 3 over 4. And c, the y-intercept. So right here in the diagram, the coordinates of Q will be 0 is to negative. Remember the gradient is negative 3 over 4. And the reason why that's important is because, guys, you remember that there's a relationship between a tangent and a radius. So we have a radius here. Let's construct it. We know that tangent is perpendicular to the radius. What that means is that the gradient of a tangent times the gradient of the radius. We already know the gradient of the tangent is negative 3 over 4. Which number do we multiply by negative 3 over 4 and get negative 1? We just switch the numbers and change the sign, and we are getting the gradient of the radius as positive 4 over 3. Now remember, as we do the questions, they will either be about circles directly, or the dominant 5, or application of other topics. Question 4.1.1. Calculate the coordinates of Q, which is the y-intercept. The y-intercept of the straight line and also the circle. But we are going to use the equation of the straight line to calculate Q. And from the information, we are given the equation of the straight line SQT, which is y is negative 3 over 4 x minus 8. And right here, we are going to apply functions, which falls under other topics. And in functions, we learned that to calculate the y-intercept, where there is x, we're going to put 0. So y is negative 3 over 4. X is now 0 minus 8. So the first part is going to be 0, and we are left with y is equal to negative 8. Therefore, the coordinates of Q will be 0 is negative 8, which we already indicated in the picture. Next customer, please. It's always important just to fill in the information you already calculated. Q0 is to negative 8. The gradient of SQT, the radius, is perpendicular to the tangent. Remember, each time when we answer a question, we need to ask ourselves whether it's a circles question directly, or it falls under the dominant 5, or application of other topics. So in question 4.1.2, they are saying determine the equation of QR in the form y is mx plus c. So this question is the application of other topics, which is functions. Remember, in functions paper 1, we learned about the equation of a line. The equation of a line can be calculated using this equation. Or this other equation which says y minus y1 is equal to gradient into x minus x1. I prefer either one of them. Let me just use y is mx plus c. So we're going to need to find the gradient and also c, which is the y-intercept. And from our earlier analysis, we've already determined that the gradient of the radius is 4/3. We just have to write how we arrived at the answer first. So we're going to say, okay, the gradient of QR, which is our radius, times the gradient of the tangent is equal to -1 because they are perpendicular lines. We already know the gradient of the tangent, which is -3/4. To get -1, we're going to say, okay, we switch and change the sign. Now let's calculate C. We already know the value of M. We need the value of Y and the value of X. We go to the line, which is line QR, and look for a point which is on the line. The point is 0 is to -8. 0 is X, -8 is Y. So where there is Y here, we put -8. M is already 4/3. Where there is X, we put 0 plus C. So C is clearly -8. So let's write down the equation in standard form. That's going to be Y is equal to 4/3 X minus 8. And checkmate. Next customer, please calculate the coordinates of P, the x-intercept of line R. Here is point P. Remember line QR, we have just calculated its equation in the previous question. And we got Y is 4/3 X minus 8. So once again, this is the application of other topics, which is functions, paper 1, where we learnt about the x-intercept. Let's do it. Where there is Y, we're going to put 0. Then solve for X. -8 will go to the left and become +8. 4/3 X. You can either divide both sides by 4/3 or you can just cross multiply. Let me just cross multiply. 8 times 3, that's 24, is equal to 4x. After that, we divide both sides by 4 to make x the subject of the formula. 24/4, that's a 6. Here we're going to cancel out. Therefore, our x-intercept is 6:0. Let's fill it in on the diagram. 6:0. And P right here. Next, calculate the coordinates of R. Nice one. So R here is the center. And what do we know so far? PQ is our diameter. Out of these 3 types of questions, which question is this? That's the dominant 5. Why? Because we learnt earlier on in this lesson that the center of the circle is actually the midpoint of a diameter. So this is a dominant 5. Midpoint question. This is the midpoint formula. And in this case, the midpoint is R, the center of the circle. Point Q, let's call it x1, y1. Point P, let's call it x2, y2. So x1 is 0, x2 is 6. 0 plus 6/2 is 2. Y1 is -8 and 0. That's -8 plus 0/2. End up with the x value as 3 and the y value as -4. Let's write it in the diagram. 3:4. Next customer, please. Write down the equation of the circle. Finally, they're asking something which is directly related to a circle. Write down the equation of the circle centered at R in the form like this. So this is a circle's question. And when it's a circles question, we have to ask ourselves, is it center origin or center away from origin? So R is away from origin. Origin is right up here. And from this formula, let's see what we have and what we don't have. Okay, firstly, the center is A is to B, which is, let's see, which is 3 is to negative 4, the coordinates of R. 3 is to negative 4. X and Y is any point on the circle, right on the circle. We can either use point Q, which is on the circle, or point P, which is on the circle. You can just pick one of them. So X is 6, Y is 0. And from these values, we can just calculate R squared, the right-hand side of the equation. Another way, guys, you can just use a distance formula to calculate R. Okay, let's go. In the place of X, I'm putting 6 minus A, which is 3, all squared plus, in the place of Y, here we have 0, minus B, which is negative 4. So since you're still substituting, it's important that you substitute as negative. R squared is going to give us 25. Therefore, the equation of the circle is X minus A, which is 3, all squared plus Y minus B. Remember here we substituted negative 4 and we already have minus. That's going to be positive 4. All squared is equal to R squared, which is 25. And checkmate. 4.1.6. If Y is K, is a tangent to the circle, determine the values or the value of K. Okay, they're saying Y is equal to K. This is the equation of a tangent. K represents a real number. Did you catch that? A number on the y-axis. And from that number, we form a tangent to the circle. Let's draw that tangent. Firstly, we make sure it touches the circle once. It's touching the circle right here, point of contact. So we want the y value right here, just above the origin. And since they are saying the values of K, there's got to be another tangent. Just under Q here, guys, the line becomes the tangent right here at this point. So we want to know the y value right here. That will be the K value because y is equal to K. K value is y value. How do we do it? We are just going to read off from what we already know, the distance from the center, that's the radius. And remember the equation of the circle has R squared, which is 25. The radius is the square root of 25, which is 5 units. So right here, R is 5. Another radius is going to another tangent right here. That's another R is 5. So let's see what the y values are. It really helps to measure everything from the origin, where everything is 0. So from here to the center, you see what the y value is negative 4. So from 0 up to right here, we have the y value, which is negative 4. In other words, this part right here is 4 units. And this part all the way to our tangent, that's radius. See this part right here, all the way to the tangent, that's our radius, which is 5 units. So from 0 to the tangent right here, that's 4 plus 5, which is how much? 9 units. So the first K value, we are saying 4 units plus 5 units. Now, since we are on the negative side of the y-axis, so this part is negative y-axis. 4 is already negative 4, and then this 5 units is going to be negative 5. Therefore, K is negative 9. So this other part, right from here, the circumference, all the way to the center, we already know is the radius, which is 5 units. And remember, from 0 up to negative 4, that's 4 units. Let's focus on the red lines. This one from point R to the tangent, that's 5 units. And this one from 0 to negative 4, that's 4 units. So all of these 5 units, these 4 units, we add how much to complete the 5 units? We add how much? We add 1. So meaning up here, the y value is equal to 1. So it came from R is 5 and y is negative 4 here. So we are saying K 5 plus negative 4. Therefore, K is equal to 1 and checkmate. Next, customer, please. The final one for now. Calculate the maximum length of the radius of the circle having this equation. This is a direct circle question. Whenever they ask about a circle, especially talking about the equation of the circle, we have to ask ourselves, is it circle center origin or away from origin? Circle center origin must look like this. X squared plus y squared is r squared. But this one right here is not looking like that. So it has to be the circle center away from origin, which is actually this form. We have to complete the square to get that standard form. And to do that, we start by writing the x terms next to each other. That's x squared. The other term with x is this one. That's minus 2x sine theta. Then we write the y terms next to each other. That's positive y squared minus 4y sine theta. Now remember, when we complete the square, we're going to be dividing the coefficient of x by 2 and later divide the coefficient of y by 2. So let's clearly show the coefficient of x and then clearly show the coefficient of y. We have x squared here minus, let's start with 2, then sine theta. So this is the coefficient of what? X. Then the coefficient of y. So we have y squared here minus, let's start with negative 4, then sine theta. So negative 4 sine theta, that's the coefficient of y, is negative 2. Okay, let's now complete the square. So we have x squared minus 2 sine theta plus x. We are going to add something and square it. What are we adding? The coefficient of x. So we take negative 2 sine theta and divide it by 2. Check this out. That's negative 2 sine theta over 2. So 2 will cancel 2. We are left with negative sine theta. Write it in brackets here, negative sine theta. Then the y's. Y squared minus 4 sine theta y. So we are going to add something again here and square it. What are we adding? We are taking the coefficient of y, which is negative 4 sine theta, and divide it by 2. So when we divide negative 4 by 2, we are getting negative 2 sine of theta. Everything is equal to negative 2. But remember, what we added on the left hand side, we must also add on the right hand side. So on the left, we added negative sine theta all squared. The question is not difficult, it's just long. We also added negative 2 sine theta all squared. All right, let's complete the square. So far, we have x squared minus 2 sine theta x. Removing the brackets, negative sine theta squared will be positive sine squared theta. The y parts, we have y squared minus 4 sine theta y. Negative 2 sine theta all squared will be positive 4 sine squared theta. On the right hand side, we have positive sine squared theta, positive 4 sine squared theta. Now the standard form of circle center away from origin. We need 2 brackets squared plus another 2 brackets squared is equal to the right hand side. In the first brackets, we need x. Next brackets, we need y. With x here, what are we writing? Let's go back to this step where we added and squared something. Right here, we added negative sine theta and squared it. So we take it right from the brackets with a sign. So that's negative sine theta. Here, with the y's, we added negative 2 sine theta. Right hand side, we still have negative 2. We are adding like terms here. 1 sine squared theta plus 4 sine squared theta will give us 5 sine squared theta. Okay, before we get carried away, let's check what the question is saying again. They are saying calculate the maximum length of the radius, meaning we are going to focus on the radius part. The maximum length of the radius of the circle having this equation. Okay, now that we have the equation in standard form, remember according to the standard form, which is this form right here, the right hand side is r squared. So here, the right hand side is r squared, which is negative 2 plus 5 sine squared theta. And they want us to calculate the maximum length of the radius. Guys, under normal circumstances, you will remember that if we are finding the radius and we have r squared, we just write the square root of whatever is on the right hand side. But the challenge we have here is that the right hand side is not a real number. Yes, negative 2 is fine, but this part right here, sine squared theta, we wish it was a number. But we are not sure what theta is exactly. Theta can represent any value. In fact, do this. Test some numbers using your calculator. So we have sine squared theta. In the place of theta, just put any value you want, guys. Do it several times and put any number you want. Okay, I did here, guys. I substituted random numbers in the place of theta. When I substituted 0, sine squared 0 gave me 0. Sine squared, just random, 80, that's negative 0.98. Negative 80, 0.98. I even went as far as negative 1,000,000, and I still got 0.98. So the conclusion I came up with, guys, was this. For any value of theta, the highest value we can get is 1. You see 0.98 is not so far from 1. If you just choose numbers randomly, one of them is going to be giving you 1. So for any value of theta you substitute, you will find that sine squared theta, its maximum is going to give us positive 1. And that's what we wanted. So here, we'll write r squared is negative 2 plus 5. In the place of sine squared, we write 1. So r squared is going to be negative 2 plus 5, that's 3. R is going to be the square root of 3. So the maximum value of the radius is the square root of 3 units. We can even just write it in decimal form as 1,73 units. And checkmate.